In this video, we're going to do a harder example involving profit. So the example is that a store's daily fixed costs of selling chewing gum are $32. The daily demand is Q of P equals 20 minus 3P, where P is the unit price. So that is our demand function. If the price that maximizes the daily profit is $7, what is the marginal cost? Okay, so at this point, I want you to pause the video for just maybe 1 to 2 minutes. And I only want you to think about how you would begin this problem. So 4, 3, 2, 1, pause the video. Pause the video for just maybe 2 minutes and think about how you'd start this. It's likely not going to be enough time to finish the problem, but just think about how you would get started. All right, so hopefully you've done that. Hopefully you've paused the video for about 2 minutes to think about how you would begin. So let's talk about it. And don't worry if whatever you thought about isn't quite right. That's okay. Part of the process is just thinking about it, and even if we're not correct initially, that's okay. We'll talk about the things in this problem that might indicate which direction we want to go. So the question is asking, like, what is the marginal cost? So somehow we're going to need to get that. But in that same sentence, it tells us a key piece of info, which is that the price that maximizes the daily profit, well, actually, let me erase that second line, that maximizes the daily profit is $7. So I just wanted to draw that a little bit better. So it tells us this key information about the profit and the price that maximizes the profit. So because of that, we will probably need to get the profit. And we know that the profit equals the revenue minus the cost. So if we want to get the profit, we need these. We need to get the revenue and the cost. We'll need to get both of those. All right, so let's begin with one of them. So maybe let's begin with cost. So let's write cost as a function of quantity, as a function of x. So for cost, we don't know what the marginal cost is, so I'll just call that m, and we'll have mx plus, and then we usually write our y-intercept. And the y-intercept represents the fixed cost. So the fixed cost here is given to us. The fixed costs, it tells us, are $32. So that's what goes here. 32, this is the fixed cost. And m is the unknown marginal cost. So the unknown marginal cost, that's m. Okay. So we have cost as a function of x. But the sentence tells us that it tells us information about the price. So maybe we will need to get cost in terms of price. And we've seen how to do that in the last video, in the example that we did. So let's just do it here as well. So the idea is x represents a quantity. And the variable that we have to refer to quantity, aside from x, is q. Okay, so now what I'm going to do is I'm going to plug in q, and what I mean by q is the demand for x. So the quantity that they sell, x or q, is the demand. Okay, so we'll plug in the demand for x. So doing that, we end up with c, and now c is going to be a function of q, no longer x. And it's going to be m times q plus 32. Okay, so now we have c as a function of q, but again, we want to try to get it in terms of price. So now, let's plug in the demand function for q. Plug in the demand function for q. And that'll give us c in terms of price. Okay, so doing this, we get c equals, now it'll be a function of p. So it equals m times, what was q equal to? So the problem tells us that q of p equals 20 minus 3p. So let's plug in 20 minus 3p for q, and then we have plus 32. And I can go ahead and distribute this and combine some like terms. So we get cp equals, and I'm going to put the negative 3mp first, because that's the term that has the variable. And then I'll put the plus 20m plus 32 after that. Okay, so we have a cost function here. Okay, so this is one of the functions that we will need for this problem. So I'm gonna highlight this. This is one of the functions that we need for this. We need the cost. Now let's go ahead and get the revenue. All right, so actually before I do that, let me just outline my work a little bit more. So here we are getting the cost. And now let's go ahead and get the revenue. All right, so let us get the revenue now. Okay, so revenue, we know that revenue R equals price times quantity, or P times Q. Okay, and just like with cost, let's get this purely in terms of P, in terms of the price. So this is going to be P times whatever Q is. So let's plug in our formula for the demand, which was 20 minus 3P. And if I distribute P, we get a quadratic. We get negative 3P squared plus 20P. Okay, and that is the revenue. Okay, so let me highlight this as well. So this is the revenue. We are going to need this. So finally, we are ready for the profit. So now we're ready to get the profit. So the profit, P, capital P, equals the revenue minus the cost. Okay, so P, profit, is the revenue, and the revenue is negative 3P squared plus 20P. It's that first, minus the cost. So the cost, what was the cost? It was negative 3MP plus, I think I might need a little bit more room here, plus 20M plus 32. So that was our cost. All right, so now let us distribute that negative sign into the parentheses and see if there are like terms we can combine. So we get capital P, profit, equals negative 3 little p squared plus 20 little p. Distributing the negative sign, we get plus 3mp minus 20m, and then minus 32. Okay, so I see two terms in the middle that have a p in them. So let's factor the p out of those two terms. So we get capital P for profit equals negative 3p squared. And now if we factor a p out of those two terms, so factor a p out, what we'll be left with is 20 plus 3m. And then after that, we still have the minus 20m minus 32. Okay, so this is a quadratic function right here. So in this quadratic function, the negative 3 is the a. The 20 plus 3m, this is the b. And the minus 20m minus 32, that's the c. In fact, let me just highlight those so they stand out a little bit better. Okay, so negative 3, that's one of the coefficients. 20 plus 3m, that's another coefficient. And then the minus 20m minus 32, that is the c, that's the constant term. So whenever we're maximizing or minimizing something using a quadratic, we always have to justify why it's a max or why it's a min. And we use a to justify that. So a is negative. And because a is negative, that means we are going to have a downward facing parabola. So let's draw a downward facing parabola, so something like this. And in a downward facing parabola at the vertex, we have a max. So we have a max at the vertex. And that's important. That's part of justifying why we have a max or why we have a min. Our argument is actually incomplete without that. All right, so now let's use the vertex formula. So let's use the vertex formula. So the vertex formula normally would be x equals negative b over 2a. But just like we saw in the example in the last video, we don't have an x as the variable here. Instead of x, we actually have p. So let's write that. P equals negative b over 2a here. So now let's plug in what these values are. So we have a negative, b is 20 plus 3m m over 2a, a being negative 3. Okay, so that's what we get from our vertex formula. And recall what the problem told us about p. Okay, also this So I should really be careful here. This is the P that represents price. In fact, let me put that in a different color just to clarify. Let me keep that in black, because the capital P that I've been using for profit, I've been writing that in blue here. Okay, in fact, just to be clear, let's put this P also in black, lowercase p. Okay, all right, so let's recall that the price that maximizes the profit equals $7. And the vertex formula tells me what P is. It tells me what the price is. The price that maximizes the profit. That happens at the vertex. So what that means is I get to plug in the 7 for lowercase p. We get 7 equals, and then simplifying this, so this negative and that negative, they cancel. We end up with 20 plus 3m over 6. And now we just need to solve this equation. So we can multiply both sides by 6 to get rid of that denominator. So multiply both sides by 6. We get 42 equals 20 plus 3m. Moving the 20 over, we get 22 equals 3m. And then I could divide by the 3. So we get m equals 22 over 3. And remember, m represented the marginal cost, so the units in this problem were dollars. So that is our marginal cost. And if we needed to put this in decimal form, this is about $7, and rounding it to 2 decimal places, 33 cents. All right, so at this point, we have done our third learning goal. We have talked about this harder maximum profit example.